Hi everyone, it's Rohan this side, and in this video I'm going to show you how to solve this entire Pure Mathematics 1 paper, Variant 2, that appeared in the Cambridge examinations during their February-March 2025 sessions. Now the way that I'm going to solve this paper is going to be slightly different than what I've been doing so far. So please let me know in the comment section that if you found this particular way useful, or should I switch it back to what I was doing it. Then I'll just stick to that versions from the upcoming, whatever kind of past papers that I'll be solving. So yes, let's get started, guys. So the first question is pretty repetitive. We are given the curve which is having this equation and a straight line which is having this equation where you can see that this k is an unknown which is a constant. And the whole idea about this question is to find the set of values of that k for which this curve and this line will never intersect with each other. I know that if I'm having a quadratic equation, my line can never meet in this particular scenario. Or it can meet with the curve when it's going to have a tangential property, or at max it can meet at two different points. So in order to find, first of all, let's say if they are going to have any kind of intersecting points or not, we need to equate the curve with the line. And once we are going to equate the curve with the line, we are going to get a new quadratic equation. Now for that new quadratic equation, because this line and the curve is never going to intersect, it means that there are no solutions for this equation. And if there are no solutions for this equation, we can utilize the property of the discriminant to be less than 0. Because when the discriminant is less than 0, we know that there are no real solutions. And therefore, we can just go ahead and solve the inequality in terms of k and solve this entire question. So yes, let's get started with the solution. I've written down the equation of the curve and the equation of a straight line. And then to understand if it's having any kind of point of intersection or not, we need to equate both of them. Once we are done equating them, we can see that it's not in the format of ax square plus bx plus c is equal to 0, which is an ideal format to start solving any quadratic equation. So I'm going to convert into that format by sending all the terms to the right hand side. And in doing so, I'm going to achieve this quadratic equation where I'm just having one term in x square, one term in x, and one term as a constant. Therefore, I can say that from this quadratic equation, which is in the format of ax square plus bx plus c is equal to 0, a is 2, b is k minus 3, and c is 8. Once I'm having this, and I know that the curve and the line are never going to intersect according to the condition in the question, the discriminant of this quadratic equation should be less than 0. And that's what I've implemented in the next step. So after doing b square minus 4ac less than 0, opening the brackets over here, I got k square minus 6k minus 55 less than 0. And then it's all about how you can solve the quadratic inequalities. So what I've done after this is I've just used my calc to factorize this equation, and I got two solutions, minus 5 and 11. So from minus 5, I got k plus 5 as a linear factor. From 11, I got k minus 11 as a linear factor. So I can just rewrite the second statement as the third statement, as you can see. After that, because I know that for my kth axis, the values are going to become minus 5 and 11. Based on that, I've just sketched a rough quadratic curve, given that the k square is positive. So I've just drawn it in the upward direction. And I want this equation to be less than 0. So this line is equal to 0. Above that is greater than 0. Below that it's less than 0. So because I want the values of k for which this equation is less than 0, I can see that the values of k must lie in between minus 5 and 11. That is how we write that my k lies in between minus 5 and 11. So that should be your final answer. So just to conclude our statement, I am writing that for all the values of k in between minus 5 to 11, the given curve and line does not intersect or does not meet. That's how you do the first question. Now let's move on to the second question. The diagram shows the curve with this equation. So both the parts of this diagram are coming from this equation. The curve crosses the x-axis at point P, whose coordinates are given to us as 1, 0. And then it's also mentioned that M is a minimum point, which is over here. In the first part, we are supposed to find the gradient of the curve at point P. So whenever we are having the equation of the curve, how do you find out the gradient of the curve? The idea is we differentiate the given curve, and once we are differentiating it, we get the equation of gradient. Then how do you find the value of the gradient? By simply substituting the value of x at which we are trying to find the gradient. So over here, I'm first going to differentiate this curve. After that, I'm going to substitute the value of x as 1 to find out the gradient at the point P. So now let me show you how I have done this part. First of all, I've just rearranged this pi by x as pi x to the power of negative 1 so that I can easily differentiate it with the help of power rule. So differentiating the 2x square, I get 4x to the power of 1. Differentiating this, I'll get positive 5x to the power of negative 2. And the differentiation of a constant is 0, so that's why I have not written it down over here. Once I'm having the equation of a gradient, now it's time to find the value of the gradient at the point P. So because this is only having x values that we need to substitute, I'm just going to say that in the second line that what is the value of the gradient at point x is equal to 1. So if I substitute x as 1 over here, you get the value as 9. And therefore we can conclude this part, gradient of the curve at the point P is 9. And now moving on to the second part, we have to find the coordinates of the point M, giving each coordinate, that is both x and y, correct to three significant figures. And whenever they mention specific type of significant figures, we strictly need to follow it. And now over here, answering this question, because we know that M is a stationary point, how do you find coordinates of any stationary point? We first need to figure out what is dy dx, which we have already done in the first part. And then we simply need to equate that to 0. Because I know that the gradient for the stationary points is always equal to 0. Over here, we can see that if I draw a tangent, it's parallel to the x-axis. And therefore, we say that all the lines parallel to x-axis have a gradient of 0. So following to that particular idea, I'm going to solve that equation to get the value of x. Once I'm having the value of x, I'll tell you what we can do next. So let's see how to solve this specific part. So over here you can see that to find out the x coordinate of m, I am doing dy dx is equal to 0 and I am writing my phi x to the power of negative 2 as phi over x square. After this, to solve it ahead, I am just multiplying my x square on both the sides so that my 4x now becomes 4x cubed, my 5 by x square becomes 5, and on the right hand side x square into 0 is still 0. And after that, you can see that I'm just trying to make x the subject of formula. And then because it's a cube root, there is only one value. There is no plus or minus over here. And that is why the only value of x you are getting over here is minus 1.08, correct to three significant figures. Now, it's very, very important that you keep in mind that in order to find out the value of y, you will need to substitute the value of x back into this equation. But then it's really very recommended that you use the exact value of the x coordinate rather than a three significant value so that you are getting more accurate answer. And that is exactly what I have done in the next line. If I can show it to you over here, my y coordinate of the m is simply going to become 2 times this value to the power of 2 minus 5 times this value to the power of negative 1. As you can see over here, it's negative 1 plus 3. Solving this in CAIE, correct to three significant figures, I am getting the value of y as 9.96. And that is why I can say that the coordinates of the point M, correct to three significant figures, is going to become minus 1.08, comma 9.96. And now let's move on to question 3 part A. Here we are asked to find the complete expansion of the given term. So this is a very classical question we get for the binomial expansion. In almost all the kind of papers we get this, so I'm assuming you are pretty well versed with this. If not, please make sure your basics are correct. But in the first place, you should know that this kind of formula exists in MF19 booklet if you are not remembering it. I'll give you a trick how you can remember it very easily. You will always have something like a plus b to the power of n. Over here, you will start from nc0 and go all the way up to ncn, where n over here is just the power, which is 4 in this case. That is why I'm starting from nc, that is 4c0, all the way up to 4c4. And then in all the terms, you can see there will be a term of a, b repeated in all the kind of terms. And then for the power of a, you can start with the power from 0 all the way up to n, which is 4 in this case. And then decrease the powers for b that starts from n and goes all the way up to 0. Because over here, as we know, n is 4, 4 minus 4 is 0. So let's see how we can implement this formula and solve part A. So as you can see, I have written down the term that is asked for us to expand. And then in all of the terms, you can see there is 4c0, 4c1, 4c2, 4c3, 4c4, and then 2x, 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 minus 3x to the power of minus 1, minus 3x to the power of minus 1 in all the terms. And then the powers of 2x are increasing from 0 all the way up to 4, and the power of the second bracket, that is minus 3x power of minus 1, is decreasing from 4 all the way down to 0. And then how do you open these brackets? I'll tell you the fastest way possible that you can use. You can just use your calculator and state that I am having 4c0, then you write 2 to the power of 0, and then minus 3 to the power of 4. Whatever is the answer will become coefficient. Once you are having the coefficient from the calci, you just need to look at what would be the power of x. In this case, the power of x will be x power of 0 and then x to the power of negative 4, which means x to the power of negative 4. So 81 you will be getting answer just by doing 4c0 times 2 to the power of 0 times minus 3 to the power of 4, and then x power of minus 4 is just a simplification over here. You can again repeat the same thing for all the terms and you will be ending up with getting this particular expansion. And then I've just said that here is our complete expansion, just starting with the positive powers, and then I'm just decreasing the powers of x. But then you can also write your final answer in this format, even that is fine. Now let's move on to the second part. They are asking us to determine the coefficient of x square in this expansion of x square plus 5, that's the first bracket. And the second bracket is the same thing that we have expanded in the previous part. And now because they have used the word hence, it basically means that we'll need to use the answer from the previous part so that we can get some kind of help to complete this particular. So what's the idea over here? How are you going to solve this? See, I know that in this expansion, I am having terms in x to the power of 4, x power of 2, then a constant term, then x power of negative 2, and then x power of negative 4. I just need to think about that if I multiply my x square with any of the given terms, which term is going to give me the output in terms of x square. So x square into a constant gives me x square. And therefore, if I multiply this x square with 216, you will see that I am going to have my first term in x square. You can see 216 times x square. Similarly, which term if I multiply my 5 with from this answer so that I can get an x square term? That is 5 into minus 96. And that is exactly what I have written over here. That is the second term in the x square. And then if you just sum up the coefficients, you will be getting minus 264. And therefore, this becomes your final answer for the last part of question 3. The coefficient of x square for the expansion of the given term is going to become minus 264. So that's how you solve question 3. And now moving on to the question 4, we are having the diagram of triangle AOB such that the sides OA and OB are equal to each other. You can see that it's 10 centimeter on each side. And then the angle over here is 0.8 radians. Along with that, we are also having the arc of a circle that is called as CD, whose center is at 0, and the radius of that circle is 6 centimeters. Along with that, we are also having the information that the shaded region over here is bounded by the arc CD, the line segments AC, BD, and AB. In the first part of this question, we are asked to find out the perimeter of this shaded region. So clearly we can see that the values of the AC and BD are known to us. We just need to find what is this arc length. I can simply find this by using the formula S is equals to R theta, and then I can find out the value of AB because I know its adjacent sides of 10 centimeters each. So I can just use the cosine rule because I also know what is the angle just opposite to the side AB. And that is how I'm going to solve the first part. So let's see what I have done over here. So if I just scroll down, the length of AB is found using the cosine rule as I've explained it already to you. The unknown side square is equal to the sum of the squares of the other two sides minus 2 times the multiplication of the other two sides time cos of the angle just opposite to the unknown side. And in doing this, if you simplify this, you will be getting AB is equal to this. Just know that I've taken more decimal places so that I can at the end round off the answer in a better place. And then after that, in order to find out the length of the arc CD, I am using the formula radius of this times the 0.8, which is the angle. So in that case, I'm getting 4.8 centimeters. Now that I'm having AB and CD both, so I just need to add the extra 4s on each side in order to just find the solution for the first part. And that is what I've done over here. The final answer for the first part, correct to three significant figures, therefore becomes 20.6 centimeters. And then for the second part, we simply need to find the area of the shaded region. I can do this by first calculating the area of this triangle, and from that area I'll just remove the area of the sector so that I'm just left with the area of the shaded region. So how can I find out the area of the triangle? Because I know there are two adjacent sides to the given angle 0.8, I can use this formula half AB sine C. So over here AB are the adjacent sides of the given angle and C is the angle that we are talking about. So that is how I'm going to find the area of the triangle, and then the area of the sector is simply calculated using half r squared theta. And in doing so, over here if I can show you my solution, so you can see that in the solution part I have done exactly the same thing. half AB sine C minus half r squared theta. If you put this in your calc, the final answer over here for the area of the shaded region you will be getting will be 21.5 centimeters square. So that is how you do this question. Now for the fifth question, I have highlighted this to be one of the most difficult question asked in this paper based on my interaction with the students. Over here, they thought initially that this was the straightforward question, but when they were comparing the answers with the marking scheme, they were just not getting it correct. So here is my attempt in order to explain you guys how to solve this one. We are having an arithmetic progression, which is having the first term as 5 and the common difference as 6. Now for this arithmetic progression, we are asked to find the summation of all the terms that lies between 150 and 400. So the most common incorrect approach by the students based on their past paper practice of this kind of questions, they thought that they were asked to find out what is the summation of the terms between the 400th term and the 150th term. So they simply did this obvious thing. They found out summation of the first 400 terms minus the summation of first 149 terms. And in doing this, they will be getting summation of all the terms between the 400th term and 150th term. But then this was the incorrect approach. Why? Because in the question, if you read it very carefully, Cambridge just played trick with you guys. Over here, we are supposed to find summation of all the terms which lies in between 150 and 400, which means that I am giving some of the example of how the arithmetic progression is going to look like over here, starting with 5, then 11, 17, so on and so forth. Now, there will be certain kind of terms in this arithmetic progression whose values will be greater than 150 but less than 400. So, you first need to identify that in this GP, there are how many terms whose values lie between 150 and 400. You just need to identify those terms and then find summation of those terms. So, I hope you got the idea about what is asked in the question and why this is going to be an incorrect approach. Over here, what are we doing? We are saying that no matter whatever is the 400th term, let's say the terms in this series, we are having the first value that is greater than 150, that is after 400th term. So we are not even including this kind of terms. If you, let's say, find out summation of the first 400 terms minus summation of the first 149 terms. And that is why that is the incorrect approach. And now let me show you how I have solved this question over here. In the first part, I have figured out what is the nth term in this arithmetic progression where the value of the term is going to be greater than 150. So for that, I have kept the value of the term as 150 so that I can find the value of n. And the term just after that will be the term where the value of the term will be greater than 150. And therefore, using the term as 150, I found out that the nth value will come out as 25.166. By the way, this is the nth term formula of AP, where I've used that the value of term is equal to a plus n minus 1 times t, where n is the nth term. So over here, the value of the n I'm getting is 25.166, which means that in this arithmetic progression, on the 26th term, I'll have a value of the term that is greater than 150. And just like that, what I've done is, I've also figured out the term that is less than 400. What is the nth value of the term which is less than 400? And in doing this process, which is exactly implementing the same formula, I got the value of n as 66.833. So the term just below that will be the term whose value will be less than 400, because on n is equal to 66.833, we are having exactly 400. So the value of n should be equal to 65, for which the term will be less than 400. And therefore, the nth term which we are interested into is from 26 all the way up to 65. That is the key terms that we are looking forward into this AP. And therefore, over here, I'll need to find out the summation of the terms that lies in between 26 to 66. And now you can use this idea that what is the summation of the first 66 terms of the AP minus the summation of the first 25 terms of this AP. And in doing this process, you will find all the summation of the terms in between 26th term to 66th term. And over here, the formula that I've used is n by 2 times 2a plus n minus 1 times d for both of the cases. And finally, the answer that we'll be ending up with will be 11275. I hope that this has given you an idea of how to solve this question. And just before we start doing the next question, I really want to bring a very important point in front of you. I've seen this even in the October November 2024 paper 1 2, and even in this paper, which is Feb March 25 paper 1 2, there is at least one question where Cambridge are trying to play with the wordings or the terminologies. So be very cautious. Like, I'm just printing this for your future paper based on, like, the new committee that we are having. They might be having some of these kind of questions where they like to play with the wordings. So the only trick to solve this kind of questions in a proper way would be understand what is exactly asked in the questions, and based on that give your best attempt. All right guys, so I just wanted to clear this with you guys. And now let's move on to the sixth question. The diagram shows the circle with the radius r such that all the coordinates over here, that is x comma y, will be positive. Over here they're just saying that my circle lies in the first quadrant. The least distance between any points on the circle and the x-axis is 8 units. So it's really very important that you can understand that between the x-axis and the circle, what is the minimum distance? Well, it's the distance that I have highlighted over here, which is 8. Just like this, the least distance between the point on the circle and the y-axis is 5. So the least distance, as you can see, is 5 over here. Now we have to state the coordinates of the center of the circle in terms of r. So clearly I can see that my x will be 5 plus r and my y coordinate will be 8 plus r. So based on this, if I can show you the solutions for the first part over here, it will be just the same, 5 plus r and 8 plus r. But now it's time to move on to the next part. Over here, given that the distance between the origin and the center of the circle is 15 units, based on that we have to identify the value of the radius. So because now we already know that the distance from the origin to the center is 15 units, I can use the distance between the 2 points formula from the AS level to find out the value of r. And in doing so, over here you will be seeing that the formula that I've used is x2 minus x1 square plus y2 minus y1 square is equal to 15 square. If I can just show it to you right over here. Because the one of the point is 0 comma 0, so 5 plus r minus 0 is just the 5 plus r. Similarly, 8 plus r minus 0 is just the 8 plus r. So 5 plus r square plus 8 plus r square is equal to 15 square. And then just go ahead, open this brackets and everything, solve this question. And the final answers for the radius you will be getting would be minus 17 and 4. Now because minus 17 is a negative value, radius cannot be negative. This means that r is equal to 4 is the only solution. Alright guys, I hope that you were able to understand both of the previous part. They were straightforward. Now let's move on to the C part. Over here, there is a point on the circle furthest from the origin denoted by point P. We have to find the gradient of the tangent to the circle at that point P. So what I'm supposed to do is, let's say there is this point which is furthest away from the origin, and this point will be such that it will be lying on this line. It will be passing from the center. And based on this, what I can say is, because I want to find the gradient at the point P that is going to be over here, I can simply find the gradient of this line, and then I can just do the negative reciprocal because both the lines are perpendicular to each other in order to find the gradient of the required line. So in order to do this, let me show you how I have done it. So first of all, we have said that let the center of the circle be the point K 9 comma 12. How am I getting 9 comma 12? Because the value of r is equal to 4 and the coordinates of the center were 5 plus r comma 8 plus r. So 5 plus 4 is 9 and 8 plus 4 is 12. So that is how I said that let there be a point called SK, which is the center of the circle, be 9 comma 12. After that, what I've done is I've just found out the value of the gradient of the line OK. What is OK? Origin till the center. And then because I know that the coordinates are 9 comma 12 and 0 comma 0, finding the gradient would be straightforward, 12 by 9. And then the gradient of the line at the point P will simply the negative reciprocal of that. And that is why I've done negative 1 over 12 by 9, which is equals to minus 3 by 4. And that is how you can say that the final answer for the part C is going to become minus 3 by 4. And now let's move on to the seventh question. The first part of this question is very straightforward, where we simply have to prove this trigonometric identity. You can go from the left hand side to the right hand side or the vice versa. In my case, I have gone from the left hand side to the right hand side. How? I have said that from the left hand side, I have converted my tan square theta as sin square theta over cos square theta. And you can see that in the same step, I am also changing the cos square theta to 1 minus cos square theta. and keeping the 5 sine square theta as it is. After that, I'm just going to go ahead and cross multiply 1 minus sine square theta with the sine square theta over here, and the 1 in the denominator of 5 sine square theta with the 3 sine square theta. And after the cross multiplication, I'll be having the common denominator of 1 minus sine square theta into 1, which is simply 1 minus sine square theta. And on the top part, I'm having 3 sine square theta coming from there. And then 5 sine square theta into 1 is 5 sine square theta. Then minus sine square theta into 5 sine square theta is minus 5 times sine to the power of 4 theta. And that's it. I'm just going to simplify this and I'm going to get the right hand side that is required for the first part. Now for the 7 part B, because they've used the word hence, they mean that we need to use something from the first part in order to solve this equation. Now the first part of the equation, that is 3 tan square theta plus 5 sine square theta, is coming from the first part itself. If I can show it to you, it's this one over here. Now I can just use the right hand side of this equation in order to solve the second part, and that is what I have done in the starting part. Now to solve this equation, I just need to refactor this whole equation, and that is what I have done over here. I have shifted my 1 minus sine square theta to the right hand side and then shifted all the terms to the left hand side so that we can get a hidden quadratic equation in terms of sine square theta. You can say that we are having 5 sine to the power of 4 theta minus 17 sine square theta plus 9. And then because 5 was having a negative sign over here in front of it, I am just multiplying the whole equation with a negative 1. And that is how I can get this hidden quadratic equation in terms of sine square theta. Over here, I tried to use my calculator to find out the value of the solutions of sine square theta, which was coming in decimals. And that is why what I did is I just used the quadratic formula over here and then just copy pasted my answers from the calculator, stating that the solution of this quadratic equation in terms of sine square theta is 0.655969 dot 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 and then 2.74403 dot dot dot. And after this over here, from the right hand side, if we take the square root of this term, we are getting 1.656, which is clearly greater than 1. And that is why we are going to reject the solutions of the theta coming from the right hand equation. So we are just left with the equation on the left hand side. That is, the square root of this will be plus minus 0.80991. And then because we are having two different equations to solve for theta, that is sine theta is equal to positive 0.80991 and sine theta is equal to negative 0.80991. And then I'm just using the class diagram in both the cases to solve this. For the positive value, I'll be having the values of the theta in the first quadrant and the second quadrant. And then when the value of the sine theta is negative, theta will lie in the third quadrant and the fourth quadrant. But then because there is a limit given to us to the domain, that is 270 degrees, it means that I cannot cross this line. And therefore there is no value of theta 4 added in this solution. But then you can find out the value of theta 1 by just taking sine inverse of 0.80991. And then you can find out the value of theta 2 by doing 180 minus theta 1. If I can show it to you, that is what I have done over here. And similarly, to find out the value of theta 3, I am going to do 180 plus the theta 1. And that is how you get these three values of the theta for this equation. And therefore, the final values as the answers for this part will be 54.1 degrees, 125.9 degrees, and 234.1 degrees, all correct to one decimal places. That's how we solve this question. All right, so once again, we are having a question on sequence and series. This is the eighth question. We are having a geometric progression such that its second term is minus 120, which means a into r is the second term, which is equals to minus 120. And the summation to infinity is 160. We have to find in the first part what is the value of the common ratio. It's very important that we keep in mind that whenever we are dealing with the sum to infinity, it means that the geometric progression sequence will be convergent, which means that the value of the common ratio must lie in between minus 1 and 1. Now, keeping that in mind, let me show you how to solve this question. I've just written down the things that AR is equals to minus 120 and then the sum to infinity is 160. So I did A over 1 minus R is equal to 160. And then from this equation, I've just said that my A will be equal to 160 minus 160R. And then because I'm having my A equal to this and I'm trying to find out the value of the common ratio, I'm going to substitute this A over here in the first equation. And in doing so, I can say that the value of the R that I'm going to get is minus half and 3 by 2. So clearly 3 by 2 is 1.5 And because 1.5 is greater than 1, we are going to reject this value of r. But then by solving this quadratic, we also got r is minus 1 by 2. So the common ratio for this geometric progression will be negative 0.5. That will be the final answer for this particular part. And then for the second part, we are having the first 9 terms of the progression, which are removed from the geometric progression. And now we have to find the sum to infinity of the remaining terms. So we were having all the terms, and from all of the terms, if we remove the first 9 terms, we'll be left with the remaining summation of the sums. And that is exactly what I've done over here. First of all, I have figured out what is the value of a. I need to find out what is my first term. So by using the equation over here that I have found out, I did 160 minus 160 times r, which is minus half, to get the first term as 240. And then I found out summation of the first 9 terms using the first 9 terms of GP, that is a times 1 minus r to the power of n divided by 1 minus r. And in doing so, I got that the summation of the first 9 terms will be equal to 160.3125. This was the exact value that I was getting from the calculator. And after that, because we are trying to find the summation of the remaining terms, I know that the summation of all the terms are going to be 160. So from the 160, if I remove 160.3125, what am I going to be left with? I am going to be left with minus 5 by 16 as the exact answer. Please note that over here, if you just say that it will be minus 0.313, it won't be considered correct. Over here, if you're getting an exact value, please make sure you're writing the exact value. Okay, just keep that in mind. Now for the ninth question, we are having a curve such that the double derivative of the curve is given as this. It is also given that the curve has a stationary point at half comma 9. And then using this expression for the double derivative, we have to determine whether the stationary point is a maxima or a minima. So the straightforward approach to this kind of question is, because we are already having the equations of the double derivative, we just need to pass in the value of x and say that if the double derivative is greater than 0 or less than 0. If it's greater than 0, it's a minima. If it's less than 0, it is maxima. And that is exactly what I've done over here. If I can show it to you, I just substituted the value of x is equals to half in this equation, and I got the value as 56. Because this is greater than 0, we are simply saying that half comma 9, the stationary point that is given to us, is a minimum point. And then in the part B, we are asked to find out the equation of the curve. So the main idea would be, we'll first integrate the double derivative to get the first derivative, that is dy dx. And after that, we are again going to integrate that dy dx in order to get the equation of the curve. And in doing this process, let me show you how to solve this question. So I'm going to take the integration of the double derivative with respect to x to first of all find out what is dy dx. And because the double derivative over here is 6x to the power of negative 4 minus 5x to the power of negative 3, if I integrate this using the power rule, I'll be ending up with minus 2x to the power of negative 3 plus 5 by 2x to the power of negative 2 plus c. Now the question is, how will you find out the value of c? Over here we know that because it's a stationary point, dy dx is equal to 0, at which we pass the value of x, which was a point of stationary point. So if we are going to pass the value of x as 1 by 2 over here, the dy dx at that point will be 0. The gradient for the stationary points are always 0. And utilizing this idea, I'm getting the value of c is equal to 6. So now that I know that the value of c is 6, I can further integrate my dy dx with respect to x to find the equation of the curve. And that is what I've done over here. I've integrated my minus 2x power of minus 3 to get x to the power of negative 2. And then I've integrated 5 by 2x power of minus 2 to get minus 2.5 x to the power of negative 1. And then I've integrated 6 to get 6x. And then there is also an integrating constant. Once I'm done with this, how will I find the integration constant? I know a point on the curve that is half comma 9. I'm going to pass the value of y as 9 when x is half in order to get the value of c is equal to 7. And therefore the equation of the curve that we are going to have would be 1 by x squared minus 5 by 2x plus 6x plus 7. So yeah, that is how we do this part. And now let's move on to question number 10. Over here we are having this diagram where you can see this curve has this beautiful equation given to us in the question, which is only valid for the values of x in between 0 to 7 for this question. There is also the tangent to the curve which is passing from the point P at the coordinate 7, 0. And this tangent also cuts the y-axis at point Q. Now, apart from that, we are given the information about the region A and region B. So region A is simply the area under the curve whose equation is given to us in the equation itself. And for the B, that region is trapped between this curve, the y-axis, and the line segment PQ. And in the first part, we are supposed to find the area of the region A, which I've simply mentioned. It's the area under the curve. And therefore, if you just integrate this from 0 to 7, you will be having the answer right away. So very easy 4 marks. Just note that you are not doing very silly mistakes because we'll be having a lot of complicated solutions, like in terms of writing. It's not that difficult, but yeah, if you're not having practice, the chances are very high that you'll be losing marks because of some kind of silly errors. So yeah, that's what I've done over here. I've taken the equation of the curve and then I'm integrating with respect to x from 0 to 7. And then just to make it a bit more cleaner, my working to be much more cleaner, I'm just going to distribute my integration sign inside this equation. And this is a very valid thing to do in integration. So yeah, I'm going to integrate my first part, the second part, and the third term. And in order to integrate the first term, what I'm doing is I'm implementing the ax plus b to the power of n rule, which is ax plus b to the power, ax plus b to the power of n plus 1 divided by n plus 1. Then the division is also having a multiplication of the derivative of the term in the numerator. That is going to be 3 in this part. So I'm applying that rule. And if you're wondering how am I getting this 4, that 4 is coming from the 4 over here, which was initially present in the question itself. And then the remaining integration is straightforward. And then I just need to pass on the limits from 0 to 7. And even over here, guys, a lot of students make some kind of errors. So just make sure you're taking everything step by step and not hurrying over here. What I've done is I've just substituted the values of 7 and used my CAIE to get the value of 181 over 9. And then when I put 0 over here, obviously these two terms gets eliminated. But over here, you will be left with 8 by 9 times 4 to the power of 3 by 2. And from the CAIE, I got that to be 64 by 9. And therefore, in doing this, I got the final value of the shaded region for the A as 13. I hope this has given you some kind of idea on how to solve the first part of this question. And then for the second part, we are supposed to find out the area of the region B, which as I mentioned was trapped between this curve, the line segment PQ, and the y-axis. So the straightforward picture over here would be that if we are able to find out the area of this triangle, and if we subtract from that area of the triangle the area of A, you will be left with the area of the region B. But for this, you will need to find out the area of the triangle. And for that, you will need to know the height of the triangle. And for that height of the triangle, you will need to figure out what is the y-intercept. Which brings us to this point that yes, we'll need to first of all find the equation of the straight line PQ. And from there, I can find out what is my y-intercept. Once I have my y-intercept, I can have the height of the triangle. I can have the base of the triangle. So I can use half into base into height in order to find out the area of the triangle. Then this question becomes very easier to solve for us. Let me show you how I have done exactly the same thing over here for us. So this was the equation of the curve that was given to us. And then gradient of the tangent at point P will simply be dy dx value at the value of x is equal to 7. Why am I doing this? Because I told you that we need to find out the line PQ. And what is the main component of the line? It is the gradient and the y-intercept. So the first thing that I'm doing over here is I'm trying to find out what will be the gradient at the point P by taking the differentiation of the given equation. And if I can show it to you, the differentiation over here would be half into 4, which is 2, then 3x plus 4 to the power of half minus 1, which is minus half. Then we also need to multiply this with the differentiation of the inner part, which is 3. And then the differentiation of minus 2x is minus 2. And for minus 6, there is no differentiation. It is constant, so it's 0. And over here, if we substitute the value of x is equal to 7, we will get the value of the gradient at the point P. And the value that we are going to get after solving this is coming out to be minus 4 by 5. So basically, we know that the gradient for this tangent is going to be minus 4 by 5. Now, because we know what is the tangent, what is the gradient of the tangent and also the point lying on the tangent, I can also find out my y-intercept. Let me show you how. So I'm going to use y is equal to mx plus c and substitute the value of y as 0, x as 7. The gradient, as I mentioned, was minus 4 by 5. And then just make c the subject of formula to get it to be 28 by 5, which means that the height of this triangle is 28 by 5 itself because y-intercept is the height itself. So because now I'm having the height of the triangle, I'm going to do half into base into height. Base is 7, height is 28 by 5. So the area of the triangle will be 98 by 5. And then from the 98 by 5, if I remove the area from part A, which is 13, I'll be left with 33 by 5 being the final answer for the part B. And here comes our final question for this paper, which is also highlighted by a single star, which means that even this was a difficult question, but not as difficult or maybe a problematic as compared to question number 5. So let's look into this one. We are having two different functions f and g, which are defined for all the real values of x, where f of x is equal to this in terms of c, and g of x is equals to this in terms of k, where both c and k are given to be the positive constants. Along with that, it is also given that the g inverse function, if we pass the value of x as 3k plus 1, should come out to be equal to c. Now, keeping this in mind, we have to show that what is the function that is the composite function g of f of x. And it should be coming out to be this particular thing. That is what we have to prove basically. So in this first part, what are we supposed to do? Now, it's a really very interesting thing to note this, that to find the composite function, obviously we are going to go ahead and perform the step that whatever is my function f, I'm going to pass this as an input to the function g, and then I'm going to get some kind of an answer. But then it will be in terms of c and k both. But in the final solution, you don't have involvement of c. And here is where a lot of students were struggling that how they can eliminate c. But then if you just look into this information, you will be able to easily understand it. You just need to find out what is my G inverse formula. And from there, you just need to pass the value of X for the G inverse and equate that to C. From there, you will be getting an equation of C in terms of K, which you can simply substitute it over here. And then you can just simplify that equation to finally get the composite function G of f of X just in terms of K. So let me show you how to solve this. So as you can see that the first part is pretty straightforward. I took the function f, that is 4x square minus c, and just substituted it inside this g. And I got 2 times 4x square minus c plus k. And then if I just open the brackets, you can see that I'm getting the answer in terms of c and k both. But now, because the final answer is just in terms of k, I'll also need to figure out what is my g inverse of x. For that, I'm going to show you the steps. I'm just replacing my g of x with x and this x with g inverse of x because we can swap the x with y's, right? That is what I'm doing over here. And then I'm going to get the formula of g inverse of x as x minus k over 2. And now because I know that I can pass the value of x as 3k plus 1 and I can then equate that value to c, I'm going to get a new equation of c just in terms of k as you can see over here. Now I'm going to take this c and put it over here and simplify this further. So if I can show it to you, I've already done that over here. 8x squared, that is coming from this, minus 2c, and c was what is given over here, plus k. And then this 2 and this 2 gets out. And finally, if you simplify, you will be getting 8x squared minus k minus 1 to be the final answer for this first part. Now let's move on to the part B of this question. We are having this equation of the curve, which is now transformed to another equation y is equal to h of x by following sequence of this given transformations. Where first of all, we are having translation of 2 and 3. Then there is a stretch factor of k with respect to y-axis. And then there is also the reflection in the x-axis. Now I really want to point out this important thing for the students who are really very confused. What do you mean by the reflection in the x-axis? So for that, I'll just draw a very rough diagram over here. Whatever I'm having, let's say, on top of the x-axis will simply be reflected in the bottom, which means that all of these values of the functions were first positive. And then over here, the same values are repeated, but now they are negative. So the reflection in the x-axis is simply done by minus of original function. If you know this rule, then solving this will become a piece of cake. Let me show you how to solve this one. To start with, I have written down that d of x is equal to this equation, and we are going to convert this d of x function into h of x. I have also listed down all the steps in format of y-axis and the x-axis. And the way that we transform these equations from d of x to h of x will be such that we start doing the transformations from the inside of the function and then we go outside. So that is what I'm going to start with the x-axis and then the y-axis. But now the steps over here really matters a lot. Over here we see that in the y-axis we first do the reflection with respect to the x-axis, that is minus of the function that I was just explaining over here, then the stretch of k and then the translation of plus 3. And in the x we're having the translation, then comes the stretch, then comes the reflection. That is the order. But now when we implement it in this format that I'm showing you right now, we always, as I mentioned earlier, we start from the inside of the function and then we just go outside. So if I have to show you that how did I come up to this conclusion that my h of x must be equal to this, let me show that to you. So initially I was starting with d of x. And then because I'm starting from the inside of the function, I'll start with the x. I'm having the translation of positive 2, which means that I'm having d of x of, d of x minus 2. That is what it means that I have translated my graph towards the right hand side. Then comes the translation part. We start in the opposite way around. Just keep that in mind when we are dealing with this kind of notations. So there will be plus 3. That is the translation of the whole function. And then to get a stretch, we are having a function. We just need to multiply that function with that stretch factor of k. And then lastly, we implement this reflection, which is just that if we are having a function and if we have to reflect in the x-axis, we take the function and multiply it with the negative sign. And that is exactly what I've done over here, exactly the same steps. Okay. And then I'm just going to open my d of x minus 2 over here. I know that x is only in one place in this equation. So over there, I'm just replacing that with x minus 2. I'm going to square that up. And yeah, that's how my h of x is going to look like. And then if I just simplify it for one last step, I don't need to oversimplify it because they have not really asked us that my final expression should be the simplified format. So I can leave my answer technically over here as it is, but then a little bit of more clearer answer is what I prefer. So yeah, minus k is outside, then 8 times x minus 2 the whole square, then plus minus 1 plus 3 is positive 2, and we are also having a negative k. I'm just taking these constants and grouping them into this bracket. So yes guys, that is how you do this part. And now let's talk about part C. We are given that the range of this function is such that h of x is always less than equal to 15. And then we have to find out the values of c and k. Please note that in the first part of the question we had mentioned that c and k are both positive. And over here we are just going to utilize this function in order to solve this. So over here it's really very important that you identify that because k is a positive value, so what's going to happen from this? I'm going to have a negative quadratic, which means that it's going to look something like this. And therefore, we are saying that for this expression of h, the quadratic expression of h, this is the vertex point, which is the maximum that we can get on the y-axis, which is equal to 15. And over here, if I'm going to multiply this negative k inside this bracket, I can also write this in the completing square formula, which is basically a times x plus b square plus c. And from here, we can get the coordinates of the vertex as minus b comma c. So I can directly say that once I'm having this part from this equation, we can equate that to 15. So over here, because this equation is independent of c, we'll be having an equation just in terms of k, which is equal to 15. We are going to solve that equation to find out the value of k first, and then let's see how we can figure out the values of c. So as you can see that I have started by simplifying this expression. I have multiplied by minus k inside this bracket. So I got 8 minus 8k times x minus 2 the whole square. And then I'm distributing my minus k inside this bracket so that it becomes minus k is positive k square. And minus k into 2 is minus 2k. And in doing this, I can clearly see that the vertex is going to become 2 comma k square minus 2k. And then because this is the maximum value in terms of y-axis is k square minus 2k, I can equate that to 15 based on our discussions that I have just done with you guys. And then k square minus 2k minus 15 is equal to 0. From here, you will be getting two values of k as 5 and minus 3. And because k is a positive constant, we can reject this over here. And then over here, if I can show you from the first part, we saw that c is equals to 2k plus 1 over 2. So we can utilize this passing the value of k that we just found out to find also the value of the c. And that is exactly what I've done. And I've said that when the value of k will be equal to 5, C will be equal to 2 times 5 plus 1 over 2, which is coming out to be 11 by 2. And therefore, the final solution of this part will be K is equal to 5 and C is equal to 11 by 2. Alright guys, so that's the end of the video over here. In case of any kind of queries related to this paper, let me know in the comments. And at the same time, if you are someone who is willing to have some kind of online live classes with me to boost up your grade, you can reach out to me on my WhatsApp number over here. Thank you so much, guys. I'll see you in the next video.